Good day, everyone. Today, we will be presenting our PETA in analytical geometry. I am John B. Ocampo,
And I'm Iana Zadwig Dumlao.
and we are from grade 10 Einstein. Today, we are tasked to answer two questions in the topic of division of line segment and finding angles between two lines. We will first start with division of line segments to be answered by Ian.
For the division of line segments, our question is, find the point of the lines passing through A, -1, and B, 4, 4, which is 3 times as far from B as from A. First, we will illustrate the question. This is the line segment AB, and this is the point B, which is passing through the segment A and B. Then we will get the ratio. Ratio AP over AB, which is B over 4B. Then we will get the ratio 1 4. Then we will find the coordinates of point P. To get the coordinates of point P, we will we will use the equation x equals x sub 1 plus r quantity x sub 2 minus x sub 1, and for the y equals y sub 1 plus r quantity y sub 2 minus y sub 1. Ahead. X equals x sub 1, which is -1, plus ratio 1/4 quantity 4 x sub 2 plus 1. Then 4 plus 1, 5. Then negative 1/4 times 5 is 5 over 4, and -4 plus 5/4 equals 1/4. So our x will be 1/4. For our y, -1 plus 1/4 times 4 plus 1. -1 plus 1/4 times 5. -1 plus 5 over 4 is 1 over 4. So the coordinates of P will be 1/4 and 1/4.
And now we will start the next question regarding angle between two lines. Okay. The question given is, find the interior angles of the polygon whose vertices are M, 3, -5, A, 3, 5, T, -2.13, 3.2, and H, -2.13, -3.2. And then we should classify the polygon. First, to make it easier, we should illustrate the polygon. Here we have the polygon, MATH, and their locations are according to their x and y axis estimates. And we can also see that I created a rectangle inside the polygon with line PX connecting line point P and point X, and point H and point M, and point H and point Y. And we will see why this is needed later. And of course, since we are finding angle between two lines, we should classify the slopes of each side. So we have MA, undefined as it is parallel to the y-axis. AT, 5 minus 3.2 is 1.8, and 3 plus 2.13 is 5.13, making the slope 1.8 over 5.13. PH is also undefined, and MH is equals to -5 plus 3.2, which is -1.8, and then 3 plus 2.13 is 5.13, making the slope -1.8 over 5.13. And then we will find the initial and terminal side of each angle, going in the counterclockwise direction. Angle M has a starting side of MA and terminal side of MH. Angle A is AT and MA. Angle T is TH and AT. And angle H is MH and TH. And now it is important to use these TX and HY as undefined cannot be used in the formula of finding an angle between two lines. To recall, an angle between two lines uses the formula of M2 or terminal side or slope of the terminal side minus M1 or the slope of the initial side all over 1 plus M1 times M2. And with the slope of undefined, we could not find this. So we create the lines Tx and Hy, which are all parallel to the x-axis. So we have their slope, Tx is equals to 0 and Hy is equals to 0 because again, they are parallel to the x-axis. And then we will need to find angle ATX and angle MHY or YHM with their starting side of TX and terminal side of AT and then starting side of or starting angle of MH and starting and terminal side of HY. Okay, let us find these two angles with our solution. First, angle ATX. We substitute. We have 1.8 over 5.13 minus 0 over 1 plus 0 times 1.8 over 5.13. This cancels out, making this only 1, and then this also cancels out, and we do not need this 1 anymore, which leaves us with 1.8 over 5.13. And we use arctan, and we get 19 degrees. Next, we have angle YHM. So we substitute yet again with 0 minus parenthesis negative 1.8 over 5.13. To erase the double negative, this becomes a plus all over 1 plus parenthesis negative 1.8 over 5.13 times 0. So again, we need to cancel this out. This becomes just 0. So it's still 1 there. And this becomes a plus sign. And since it's 0, this cancels out again. So this just becomes plus. Okay, so again, we don't need the over 1. So we have 1.8 over 5.13. Then again, we use arctan. And we come up with arctan 1.8 over 5.13, also resulting to 19 degrees. But this is not the final answer as it only supplies a small portion of angle T. So, move this aside and try to find the actual angles of vertices. So first we have angle T. Angle T is a combination of angle ATX, which is 19 degrees, and a 90-degree angle created by this vertical or for this line parallel to the x-axis plus 90 degrees. We sum that up to 109 degrees. And this is one of the final answers that we need. And then for angle H, we do the same with 19 degrees plus again the right angle created by the line parallel to the horizontal axis or x-axis, 90 degrees is equals to 109 degrees. And this is yet again a final answer. Angle T and angle H. And now we need to find angle A and angle M. Let's start with angle A, as it is on the upper side of our polygon. Angle A. So how do we find this using the current measurements or angles that we find? Well, as we can see, this line actually creates a triangle. And inside triangles, we have interior angles, or the sum of interior angles is 180 degrees. Since this is a 90 degree or a right triangle, we have 90 degrees here. And then what we found, 19 degrees plus 19 degrees. And then these two, we need to subtract both of them from 180 degrees, or the sum of all interior angles of a triangle. And we have 180 degrees minus 109. So we have 171 degrees. Finally, again, this is another final answer. Okay. The last angle that we are supposed to find is angle M. And we have angle M is equals to 80 degrees minus 90 plus 19. Since you already found that, let's just substitute it to 190 degrees. And again, the same answer is 71 degrees. And yet again, this is a final answer. And now we have found all the interior angles of the polygon. So now we should classify it. And now we have the final angles. Angle M is equals to 71 degrees. Angle A is equals to 71 degrees. Angle T is 109. And angle H is 109 degrees. So let's now give our focus to the polygon as we are trying to classify it. Since MA and TH share a similar slope of undefined, which means that they are parallel to which means they are both parallel to the y-axis. This also means that they are both parallel to one another. So we can assume that MA is parallel to TH. And then we find that angles M and angle A are congruent, and angle C and angle H are also congruent. Just from the parallel sides, we can assume that this polygon or this quadrilateral is a trapezoid, as it has one set of opposite sides that are parallel to one another. Additionally, since the base angles are congruent to one another, it means that this is an isosceles trapezoid. And that is the final classification and the answer to this question. Thank you. Bye bye.
Na okay na